Hi everyone, this is K1C from ECD session. So today I want to discuss about the concept of impedance and admittance in the electrical circuits. Now getting into the topic, first, what's in impedance? Is the measure of opposition that is circuit presents to the passage of current when a voltage is applied. In quantitative terms, it is the complex ratio of the voltage to the current in alternative current circuits. So AC steady state analysis using phasors allow us to express the relationship between current and voltage using a formula looked like a Ohm's law. So you can find the impedance using the Ohm's law in AC circuit, which is V equal to I into Z. Here Z is called impedance and unit has a ohms like resistance. So here you can see the formulas of impedance in resistor and inductor and capacitor. So resistor, coming to the resistor, V equal to I into R, and the impedance is ZR equal to R, where R denotes the resistance and Z denotes the impedance. And in coming to the inductor, V equal to I into J omega L, where the impedance is ZL equal to J omega L. Here Z is equal to Z omega L, where we get the impedance in the inductor. And coming to the capacitor, it is V equal to I into 1 by J omega C, and impedance is 1 by J omega C. In complex circuits, impedance is J equal to R plus Xj, where R is the resistance and X is the reactance, and magnitude of impedance is under root of R square plus X square, and angle is tan inverse X by R, where X is reactance of conductor minus reactance of capacitor, and admittance is reciprocity of impedance. And coming to the Xc, it is equal to 1 by 2 pi Fc angle minus 90 degrees, and coming to the reactance of load of inductor, 2 pi Fl angle 90 degrees. So here you can see some thoughts of on impedance. So impedance depends on the frequency, where denotes using omega equal to 2 pi f, and impedance is a complex number. Impedance is not a phasor. Why? And impedance allow us to use the same solution technique for AC studies as we use for DC steady state. And you can see the complete formulas for the impedance in different electrical elements like capacitor, inductor and resistor. So here impedance generic component that is represent a resistor or inductor or capacitor in AC circuits. So Z equal to mod Z angle phase, and these are the formulas we seen above. And coming to the example to find the equivalent impedance, here we have the current source 5 milliampere angle 0 degrees, and Z equivalence, where Z is impedance, equal to 1000 into minus J 3.5 by 1000 minus J 3.5. And for parallel impedances, Z equal to 10 power 3 angle 0 degrees into 3.5 angle minus 90 degrees by 1000 into angle minus 0.2 degrees. So we get the equivalent impedance as 3.5 ohm angle minus 89.8 degrees. So coming to the admittance, we completed the impedance, and coming to the admittance, in AC circuits we define admittance, which is denoted by Y, as being equal to reciprocal of impedance, just as a conductance is related to 1 by R in DC circuits. The unit of measurement of impedance is Siemens. It is SI system which has the symbol S. So admittance has the unit S. Admittance is a measure of how well an AC circuit will admit or allow current to flow in the circuit, and the large value of admittance, the heavier current flow for the same applied potential. And you can see the formulas for the admittance. For inductor, YL equal to 1 by ZL and equal to 1 by XL, where XL is the reactance of inductor into angle 90 degrees, and BL equal to 1 by reactance of inductor, and here we denotes reciprocal of reactance of inductor equal to BL. So we get admittance equal to BL angle minus 90 degrees. And for coming to the capacitor, YC equal to 1 by ZC equal to 1 by ZC angle minus 90 degrees minus 1 by XC angle 90 degrees. So at last we get the admittance of capacitance equal to BC into angle 90 degrees. So here you can see the formulas for calculating the total impedance admittance of a circuit can also be found by finding the sum of the parallel admittance. So when the admittance connected in parallel, we get the total admittance by the summation of each admittance element. So total impedance Z of the circuit is then reciprocal of admittance. So 1 by ZT equal to 1 by Z1 plus 1 by Z2 up to 1 by plus 1 by Zn. So we know the conductance is reciprocal of resistance, and YR equal to, where YR is the impedance of resistance, admittance of resistance equal to 1 by ZR equal to 1 by R angle 0 degrees equal to, where 1 by R equal to conductance denoted by G angle 0 degrees. So for any configuration like series, parallel, etc., the angle associated with the total admittance is the angle by which the source current leads the applied voltage E. For inductive networks, theta t is negative, whereas for capacitive network, theta t is positive. Here theta t is the angle which leads to the applied voltage. For parallel AC circuit, the admittance diagram is used with the three admittance represented as below shown in figure. Now note that conductance like resistance is one of the positive real axis, whereas inductance and capacitive suspectances are in direct opposition on the imaginary axis. So here you can see the graph which denotes the reactance, inductance, equivalent admittance of reactance, inductance and resistance. Here conductance as positive x-axis and admittance of inductor in negative y-axis, and admittance of capacitor in the positive y-axis. So we can see the problem to know in detail. Find the admittance of the each parallel branch. So from the circuit diagram, YR equal to G into angle 0 degrees equal to 1 by 5 ohms angle 0 degrees. We get 0.2 is split Z0. And for admittance of inductor, BL into angle minus 90 degrees, we get 0 minus Z into 0.125 S. And for admittance of capacitor, BC into angle 90 degrees, we get the 0.0 plus Z j, j into 0.050 s. And in and another example, calculate the determine the input admittance and calculate the input admittance from the. So here you can calculate the input admittance and input impedance from the circuit by yt equal to yr plus yl plus yc. Here total admittance is summation of the admittance of each resistor and inductor and capacity. So we get 0.2136 angle minus 20.56 degrees. And coming to the impedance, 1 by 0.2136 angle minus 20.56 degrees equal to 4.68 ohms angle 20.56 degrees. So here is the another example for the calculation of admittance and each elements. And a graph denotes the admittance of the circuits. So here here to calculate the admittance in the parallel networks, we include some steps like step 1 determine the total impedance or admittance using the ohms. In step 2 using ohms law calculate source current, calculate branch currents, and step 3 apply KCL and calculate power. So these are the formulas to calculate the admittance in the parallel AC networks. So here is the example where we calculate the admittance in the parallel AC networks. So these are the formulas used to calculate the admittance. So here inductors act like a short circuit under DC conditions and like open circuit at a very high frequency, and capacitors act like open circuits under DC conditions and like short circuit at high frequency. So I think you understand about the admittance and impedance.